All right. All right. Um. Politics and religion. Join. Okay. And let's check the audio.
How to use it. But where in the non-relativistic regime, it makes exactly the same predictions. So you can't look at an experiment. There never has been an experiment that somebody could point to that experiment and say, "Oh, that experiment shows that this theory is wrong." If it did, it would, in any normal sense, show
main theory. So critics, I didn't get it
it makes exactly the same predictions
check
as
the
standard
audio.
non-relativistic quantum mechanics. Where how to use it. But where in the non-relativistic regime, it makes exactly the same predictions. So you can't look at an experiment.
Okay. Very good. Notifications. Nothing interesting. My little brother yeeted himself because he was an incel?
Let's just get right into this, guys. The title of this post: My little brother killed himself because he couldn't get a girlfriend. Right off that title, let's just do gut responses. What do you guys think?
Mood.
Great. What do you think? Chaz, you have a younger brother?
Yeah.
You do. What if he yeeted himself because he couldn't get a girlfriend?
It would break my heart.
Yeah. Incels. People roast incels. They treat incel as a dirty word. You know the majority of 17-year-old boys are incels?
I'm not surprised at that stat.
I mean, I was an incel at 14. I have a friend who isn't really an incel. He's a virgin, but he's not an incel. He doesn't drown. When my friend B-Made, he went to a friend's wedding, and he got jealous. Why do you think my virgin friend B-Made got jealous at a wedding?
I was getting laid. Like he was, yeah, like
okay. Because someone was getting laid. It's complete opposite. He didn't call me up. This man called me up at 2 a.m. He never answers me. He takes like 5 hours to answer me.
Hello.
What up?
What up? What do you want to talk about?
I want to talk about Minecraft.
I don't know anything about that. I'm not a gamer.
You are not a gamer?
No, I'm old. I'm old.
How old are you?
Just under 100 billion trillion years old.
No. How old are you, bro?
Are you 17?
No.
And a half?
Close. 18.
Okay. So, why do you play? What's the purpose of this game? Is there a purpose?
The purpose is not exactly there. It's more of like just building and making technology and an exploration.
What do you mean exploration? Do you meet other people?
This is my friend's house.
What does that mean? I don't know what that means. So,
I play with my friend. It's a server.
It's a server like a Discord server?
Like the people, like other people can join my world and they can play with me, like actual real people.
Right. But this is your friend. But this is your friend's server. It's not your server.
It is my server. It's my world. It's like I'm the owner of it.
But you said it's your friend's house.
Well, it's my world because I host the world, but they can play with me.
What did you mean when you said it's your friend's house?
He built it, and it's his house. Like he made it.
You mean this
It's
house?
his.
The house we're looking at?
This.
Okay, okay. So your friend built it and you're helping him? You're like taking care of the garden?
Yeah, I'm just making the area look nicer. I'm trying to make everything like look, organized, good.
Hmm.
I'm adding torches so no mobs spawn because if there's no light, then at night mobs spawn, like a Minecraft thing.
I don't know what you're saying. Mob spawn?
Mobs like zombies, skeletons.
So what? So you like mobs? You like zombies? You don't like them?
No, they're bad. I have
Okay.
to put torches down to make light so they don't spawn.
Oh, so they don't spawn. Okay. Mhm.
Yeah,
Mhm.
because they're kakale poo poo.
Mhm. Okay. And so you go on like this forever?
I mean, not really. I'm not planning on playing on this forever. I'm just planning to make everything I can, and then I stop.
Mhm.
Like every single item in the game, all of them. And there's a lot because look, oh my, look,
Mhm.
there's other planets you can go to, and these are not all the planets you can go to. There's other stars, and all the stars have like 20 planets or more,
Mhm.
and they have different content. Then I got so if you look, there is 319 pages of items, and every page has this amount of items. So
Mhm.
yeah,
Do
and I
you,
want to make all of them.
and do you meet girls in this game?
Sometimes people, girls play with me, yeah.
Mhm.
Like it's only people that I invite to the server. It's not a public server.
Hmm. Can you make it public?
I mean, it's not like so. The way it works is I have a mod. You know what a mod is?
Yeah. Mhm.
I have a mod which basically allows people to just join me. Like
Mhm.
basically, they download the mod, and then with the mod they can join me. That's literally it.
A mod is like a robot?
A mod like a modification for the game.
Oh, I thought a moderator. Oh, okay.
No. Look, all these are mods. You see all this stuff?
Mhm.
This is not vanilla Minecraft.
Mhm.
Vanilla means like default.
Mhm.
This is not vanilla Minecraft. This is vanilla. This is not vanilla. Like there's so much shit.
Mhm.
Yeah, and I'm currently just making the area like flat and nice.
Are you in America?
Like in real life?
Yeah.
No.
Are you European?
Yes.
Where are you?
Moldova.
Hmm. Are you a YouTuber?
Yes.
So right now you're on YouTube?
Yes.
Am I on your YouTube?
No. Unless you want me to be. Unless you want, I won't put you on YouTube. Like I ask every time I record somebody.
Hmm. You're right now on my YouTube.
Really?
Yeah, I stopped asking.
Huh.
I just put it in my profile, and usually, when if they don't like it, and when they find out, they leave.
I don't care.
Yeah.
Can I advertise my YouTube channel?
Yeah. Yeah. Go ahead.
Subscribe to Mr. Slave on his YouTube channel and subscribe to my YouTube channel, which is Super Duper Mega Ultra Atheist.
You're an atheist?
Yeah.
I bet I could prove to you you're not.
You're proving to me that I'm not an atheist?
Yes.
How would you do that?
The same way I've done it with every other atheist I've ever met.
Define atheist.
Mm,
Because you might have a different version of atheism than me.
Let me think. How did I do it? Last time worked really well.
I'm
Mhm.
specifically an agnostic atheist,
Mhm.
so I'm not sure if you how you're gonna disprove that, but try.
I don't remember how I did it last time. Oh my god. All right. So an atheist. So you don't believe. So you're an agnostic atheist. That means there might be a god.
Yes,
That's not an atheist.
atheism is not claiming God doesn't exist. Atheism is not believing in God. There's a difference.
Atheism, literally, if you want, it means no god. Atheism is godless.
Not necessarily. So atheism is not believing in God. It's not a claim. No one claims. An atheist doesn't claim God doesn't exist. A Gnostic atheist claims God doesn't exist. A Gnostic atheist would be Gnostic, meaning knowledge, meaning atheist that he knows God doesn't exist. I am not a Gnostic atheist. I'm an agnostic atheist. And agnostic atheist means I don't believe in God. I don't claim he doesn't exist. There might be a God. And I don't know if there's a God. So I'm an agnostic. I don't know if there's a God. And I'm an atheist. I don't believe in God. He might exist. I don't. Or I don't believe in it until I get evidence.
I'm a little lost. So you're so
Okay.
so you are you overweight?
What's that to do with anything?
That precedes everything. You can't be overweight. What are you eating? You eating what is
A
that?
donut.
Why would you
I'm
eat it?
fat. I eat.
No. Do you exercise?
I do. I go to the gym.
Really? So why are you eating it? Do you eat protein?
Yeah. I mean, I can eat anything I want as long as I'm in the calorie deficiency.
Are you in a deficiency? Are you yeah?
Yeah.
Mhm.
Well, maybe not in deficiency, but I'm not eating too much. I have like around 2,000 calories per day.
How tall are you?
5'8".
How much do you weigh?
Uh, I weigh 110 kilograms, which is overweight.
110 kilograms? And you're
Mhm.
5'8"? Let me see your bicep. Make a muscle.
I mean, I don't have a bicep. I barely have anything, but
What do you do at the gym?
treadmill
So you're only doing cardio?
until I lose weight. Yeah.
You don't lose weight. That's not. I don't think that's a good way to lose weight. I mean, to lose weight, you just need to be in a calorie deficiency, but you don't want to lose weight. That's not a good target.
Why not?
What are you drinking?
Pepsi, no sugar.
Jesus. All right. But it has
Why are
caffeine.
we talking about this? What?
Because I don't want, like, I care for you. What is more important than your health right now?
God.
God is more important than your health?
Yes.
Mm-hmm. Mm-hmm.
Apparently, God is more important than everything else. So
And you have a man bun?
yeah,
Why would you do that?
I like long hair.
Jesus Christ. Oh my God.
What?
I mean, I don't want to judge you. Like, I don't want to be overly judgmental. So,
1 sec. I'll be right back.
okay.
Gotta go to the bathroom.
Okay. Tilala. Let me send this guy a friend request. He's a nice guy. Tilala. La la la. I should do that. YT in bio. Agnostic, existentialist, nihilist, absurdist, pro abortion, pro gun, moral, subjectivist, moral, viewful bio. moral realist, evolutionist, astronomy enthusiast. Is that how you spell enthusiast? Not with an E? Te la 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 la, I guess with an A, yeah. La la la. Debate me in Discord, GG. Politics and religion. PR member, room leader, room operator. RO is God real? Atheist. Relativist, nihilist. Europe. Male. Pro-choice. Evolutionist. Super duper mega ultra. Let's see his channel. La la la. Wow, 438 subs. Wait, did he just leave us? La la la. Debate about contingency argument for God? What? Does he do any live? No live. So he just records. Debate about contingency argument for God. Debate me, episode 4. So just 5 videos? 5 videos. That's not that much. I'm a super duper mega ultra atheist. That's me. Well, that is a very funny name. Please subscribe. Very funny guy. Ta-da. Wait, why did the add friend go away? Friend request failed. Didn't work. Where's my door? Oh, and he's blocked. Wave. You can't wave to him. You can't do anything. All right. Okay. What's going on with this channel? Yeah, there's no one here. La 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 la. Wait, did I subscribe? I hope so. All right. Let's put this link.
We're 3 time zones away. They want a game tonight. They want to do this tonight.
Mm-hmm.
Fair standard non-relativistic makes clear predictions. There's some situations where you actually don't even know how to use the standard apparatus, but where this theory you do know how to use it. But where in the non-relativistic regime it makes exactly the same predictions.
Anyway, I need to understand exactly what is the data we have. I need to go over the data because my realization today, I realized last night as I was, I think, going to sleep, suddenly it hit me that Alice and Bob instant communication doesn't help Alice and Bob to communicate the correlation of the detection of the entanglement. We'll come back to this paper. I need to figure out the story with this, but we'll come back to it. The software simulation proof. So right now I'm trying to think, and this is why I keep listening to this guy, to Tim Maudlin. He's basically the only one who is, I would say, as close as possible to my position. He is very close to my position that about everything that has to do with at least entanglement. So the question is, when you have 2 entangled particles and you send them to Bob and Alice, and Bob and Alice simultaneously run a detection. So when, like, let me explain this. This is very important. La la. I wish this wouldn't get. Oh, I can hide it. Oh, that's good. La 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 la. La 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 la. La 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 la. We don't need this. Why did it not go away though? Oh my god. Put it back and get rid of it again. Much better. Oh my god. Yes. Yeah. Is this the center? Okay, so what I want to do is, so let's say we're the referee. Here we are. We create a pair of entangled particles and we send them to Alice and to Bob. So we send one particle to Alice and one particle to Bob. All right. Now Alice and Bob. Now we're going to send a lightning bolt, and Alice and Bob are going to see the lightning bulb, and then they're going to run the experiment. Or they can run the experiment as soon as they get the particle, the entangled particle. But let's say we have a lightning bolt. Forget about that. It just complicates it. All right. So as soon as Alice and Bob get the particle, they're going to run an experiment. And let's say Alice runs the experiment and she gets up, and Bob runs the experiment, and we know that he's going to get down. Or let's assume they're testing the equipment. They're both testing up. Everything else is identical. They're both testing up. The magnetic field points up. They run the particle through the magnetic field. Alice gets the up result. We know and we confirm each time. Bob gets the down result. Okay, this is standard. Now, so one of the explanations, right? So this in itself is weird. How does this happen? How does this happen? We know that when we send non-entangled particles, then in those cases, it's random. 50% of the time, Alice gets up, and 50% of the time, she gets them down. And there's no correlation to the ups and downs that Bob gets. That's in case the particles are not entangled. So when the particles are not entangled, then Alice and Bob could both have up, and Alice and Bob can both have down, or vice versa. Or there's no correlation between their results when the particles are not entangled. But when the particles are entangled, when we sent two particles that are a result of the decay of a single particle, that's whatever entangled means, then if Alice measures up, then Bob always measures down. So how does that happen? So we're assuming that just like non-entangled particles are random, we're assuming that the entangled particle is also random. However random it is, it must be the opposite. We know the reason. The reason is because of conservation of angular momentum. There's actually a reason for it. But that's not good enough. So so quickly forget about the logic behind the reasons. Mm, how does it work? So I think each particle, each entangled particle that is received, right? We don't know where it's pointing. But we could say that if we measured it up, then it must have been pointing up. We could say that that is how it works, but that's not the reason why. Because we have evidence to believe that even when the particle is pointing down, some of the time we're going to measure it up. How do we know that? The answer is in the paper. Let's. We need this video. This video explained it.
Often comes up with interesting questions. Now, I don't remember how I answered her, but broadly speaking, quantum mechanics is a physics theory that describes the behavior of atoms and even smaller particles. But quantum entanglement allows for weird quantum behaviors to be seen on sizes as big as people or even larger. So just what is quantum entanglement? In an early brushing over many deep, in principle, what configuration the particle is in. To give a concrete example of what I mean by the word configuration, let's use the direction of the spin of a particle. Now, there is a quantum weirdness, or exactly opposite. It couldn't be up or down, forward or back, or any direction except for right or left. On the other hand, if you decided to measure in the vertical direction, the only outcomes of your measurement would be up and down. Left and right would be forbidden. It's certainly counterintuitive, but it's just a weird fact of life in the quantum world. Now, prior to the measurement, the wave function might say that the spin axis of the particle could be in any direction. Indeed, the most popular understanding of quantum mechanics says that the spin direction actually is in all directions allowed by the wave function. It's only when you make a measurement that the wave function collapses and the outcome becomes weird. If you'd like more information on wave functions, that other video might help. Now, what would happen if you had two subatomic particles? If you're like me, you'd think that they'd both be governed by an individual probabilistic wave function, and they'd be totally independent, with the spin direction of one particle having nothing to do with the spin direction of the other, and both of them being in all directions until a measurement is made. And that happens with four possible outcomes: two wave functions and two probabilities with all combinations of up and down. However, it's possible to prepare two subatomic particles so they both are described by a single wave function. That's what we mean by entangled: two particles and a single wave function. You do this by taking a parent particle, which in our example has zero spin, and let it decay into two particles. Spin is a conserved quantity, which means that it can never change. So if the parent particle has zero spin, then the two daughter particles have to have opposite spin. If one has a spin pointing left, the other is right. If one is up, the other is down, and so on. When you add the two, you get the zero that you started with. So that's the simplest example of a pair of entangled particles, which is to say two particles with opposite spin and a single wave function that governs both of them. Okay, so now we're getting somewhere. The entanglement doesn't depend on the two particles being close to one another. As long as the two particles don't interact with anything, you can separate them by feet, miles, or even huge distances, and the two particles are connected by a single wave function, and the two particles will have opposite spin. Now, remember that one of the key facets of quantum mechanics is that the quantum world is intrinsically probabilistic. We can't know, even in principle, the outcome of a measurement before we make it. So, suppose we select one of the two particles and pick a direction to measure the spin. Say we pick horizontal. The measured spin will be either right or left, each 50% of the time. We could have selected the other particle to do the measurement with the same result, 50% right and 50% left. The real weirdness arises when we measure the spin direction of both of the entangled particles. Say we measure the horizontal spin direction of this particle over here on the left, and the measurement says it's to the right. Then we know that the outcome of the other measurement, it will be 100% of the time left, 100% of the time. That means that the information that one of the two particles had a measurement made on it was transported to the other particle. And here's the spooky thing. We can measure the spin direction of the two.
No, you don't have to say that. I mean, you could say that the two particles were pointing in opposite directions. We measured one of them.
That one of the two particles had a measurement made on it was transported to the other particle.
No.
And here's the it says it's to the right. Then we know that the outcome of the other measurement, it will be 100% of the time.
So how does this work? So it could be that this particle was pointing to the right hemisphere of the universe. And that's why we measured it to the right. But because this one is pointing to the right hemisphere of the universe, this one must be pointing to the right, exactly opposite direction. Well, we don't know exactly where the particle one was pointing. All we know is that since we measured it towards the right hemisphere of the universe, then it must have been pointing at the right hemisphere of the universe. The opposite of that hemisphere of the universe is the left hemisphere of the universe. Namely, particle 2 is pointing at the left hemisphere of the universe. And this explains this result perfectly without instant communication.
Left 100% of the time. That means that the information that one of the two particles had a measurement made on it was transported to the other
No, it doesn't. That doesn't mean. That's not true.
particle. And here's the spooky thing. We can measure the spin direction of the two particles in quick succession so quickly that we measure the second one before any conceivable information from the first measurement could arrive.
That's okay.
Let's be super concrete on this by remembering that the fastest thing in the universe is light. It travels a foot in a billionth of a second. Now, let's take two entangled particles and separate them by 10 feet. It will take light 10 billionths of a second to travel from one to the other. So now let's get tricky. We'll measure the horizontal spin of one of the two particles and see that it's to the right. Then, 5 billionths of a second later, we measure the horizontal spin of the other particle. We find 100% of the time that it's to the left. And remember that we did it so fast that not even light could have told the second.
No, you could do it exactly as I'm suggesting. You can run the experiment simultaneously according to a center referee, so that you don't even have to think about who sent information to whom, because according to the referee, they both ran the experiment simultaneously.
Second particle, the outcome of the measurement of the first particle. That means that quantum information can travel faster than light. Yeah, you heard me right, faster than light. That blew Einstein's mind, too. In fact, he co-authored a paper in 1935 with Boris Podolsky and Nathan.
So far, that's not true. This did not blow Einstein's mind. This can easily be explained by hidden variables. That's not a problem.
Rosen that highlighted this problem. He also called this transfer of quantum information spooky action at a distance.
No. This can be explained easily away with a hidden variable. So that's not correct. For this, we actually don't even need a hidden variable. This can be easily explained even without a hidden variable.
This was one of many reasons why Einstein didn't like quantum mechanics.
No, that's not the reason why Einstein didn't like quantum mechanics.
So what do we think about this phenomenon?
He didn't like quantum mechanics because of a very, very specific experiment that you're not describing.
Today, does quantum information move at speeds faster than light? Yeah, it seems to. But it doesn't invalidate Einstein's theory of
No, my God, you're so... And of course it does invalidate, but it doesn't... But the way you described it, you can explain it away. Oh my God. The problem with quantum entanglement is that there's so much misunderstanding around it. I mean, there is a problem, but there's also a problem that everyone misunderstands it.
theory of relativity because we can't control it. We can make both measurements and the outcome will seem random, and we'll only know that the two were opposite when we compare the measurements, and that information can be transferred no faster than the speed of light. So that saves Einstein's theory, which is a relief. Otherwise,
No. If the information travels faster than light, then that destroys Einstein's relativity, yes.
I have to learn a whole bunch of physics. But it's still perplexing. How is it that quantum mechanics can travel so fast? Well, there were some people,
You have to make up your mind.
including Einstein, who thought that this wasn't so mysterious after all. Supposedly you had a
You are so confusing. Like every sentence you're saying contradicts the previous one, and I'm not even here to debate you. I'm just here to try to remember why it doesn't matter where the particle is pointing. You can always get a completely random result.
red and a blue ball, but you couldn't look at them. You grab both of them and put them in boxes and separate the boxes. Later, you look in one of the boxes and see that it contains a blue ball. It will surprise nobody that the other ball is red. The answer was determined at the moment the balls were put in the boxes, not when the first ball was observed. And I admit, when I first heard about this, that was pretty much my reaction. The technical name for this more ordinary connection is called hidden variables. So the question is, how do we
That's not a hidden variable. I don't think that's a hidden variable.
know that there's something new and different about quantum mechanics? How can we test the idea of quantum entanglement and compare it to the more intuitive idea of hidden variables? There's a long history of this, with a prediction in 1964 by theorist John Bell and a test in 1981 by Elaine Aspect, as well as contributions by many others. I'm going to forgo the history and the details of the mathematics of the predictions and just explain the measurement. We know that if we measure the spin direction of one particle, that the other one will be in the opposite direction. Well, let's change it up. Suppose that we measure the spin of the second particle in a totally different direction. How does that change things? Let's measure the direction of the first particle in the vertical direction, but the second one in the horizontal direction. That means that when you measure the spin of the second particle, it will be either right or left. That's weird, but remember, that's how this works for quantum spin.
So let's see. So if we measure the particle 1 in the up and down, and we found out that it's up, that means, let's assume that it was pointing at the top hemisphere of the universe. This means this particle is pointing at the bottom hemisphere of the universe. So if we measure it left and right, half of the time, right? Half of the time we're gonna right of the bottom half of the universe. Half of the time we're gonna measure it on the right bottom half of the universe, and half the time we're gonna measure it as if it's on the left half of the bottom half of the universe. Okay.
Spin measurements. Now, I'm going to simplify the discussion by only talking about the situation when the spin direction measured for the first particle is just up. We could be more general and include both up and down cases, but it's more confusing, and the answer is absolutely identical. If you want to do the general case, let me invoke the phrase that physics professors love and students hate, which is the exercise is left to the student. Okay, now let's get into both the quantum and hidden variable predictions. The first measurement is in the vertical direction, and it finds the particle has spin up. When you measure the spin of the second, you measure it in the horizontal direction, and you get right and left with equal probability. The first measurement gives you zero predictive information about the second measurement. It turns out that both quantum mechanics and hidden variables make the same prediction for this scenario. This is very different from if you made the second measurement in the vertical direction, because if you did, you'd get a second measurement in the downward direction 100% of the time. Again, this is the same for both quantum mechanics and hidden variables. So now we're ready for the final bit, which is to look at all possible measurement directions for the second particle and see if the predictions are different for quantum mechanics and hidden variables. We will still assume that the spin direction measurement for the first particle is upward, and then measure the spin direction for the second particle, starting upward and then slowly spinning the measurement through 360.
So if the first one measured up, that means this guy, particle 2, must be pointing at the bottom half of the universe. That means that at this detection, right, if it's at the bottom half of the universe, at most it could be pointing perfectly to the right, right? Because this one is up, that means it's pointing anywhere at the top half of the universe. That means this guy must be pointing at the bottom half of the universe. That means any experiment that we run at 45 degrees or so should be always zero. We should never detect particle 2 at 45 degrees because we said it's pointing at the bottom half of the universe. But nevertheless, sometimes we do get measurements. We get measurements even, except for when it's perfectly up. But from perfectly up, even at 1 degree, we already get some measurements. That's the beginning of the confusion. All right. But let's see what he says.
Degrees. This graph shows the predictions of how often the second measurement will be in the direction the second arrow is pointing. If the second arrow is pointing upward, we know that the second measurement is always downward. So that means the second measurement agrees 0% of the time. If the second arrow is pointing at 90 degrees to the right, the second measurement can be right or left with equal probability. So it will be to the right only 50% of the time. If the second arrow is pointing...
I'm going to wait for him to complete the graph with the data because the data will show what I want to show.
Downward, we know that the second measurement always is downward.
And he should have started from the data because everything else depends on the data.
So it is in that direction 100% of the time. And as we go to 360 degrees, the pattern is reversed. It's very important that we see that the predictions from hidden variables in quantum mechanics are different. This is key. So those are predictions. What does a measurement say? Well, these black dots show the measurement, and they are quite definitive. Quantum mechanics is correct, and the whole idea of hidden variables is completely ruled out.
Okay. One more? Yeah, perfect. So what does this say? The black dots is the data. This says that at 0 degrees, what is 0 degrees? Measurement direction relative to what? So I'm assuming 0 degrees means perfectly up. That's 0. Like the particle 1 up is always up. That's 0. Particle 2, the measurement apparatus pointing up, that's 0. So at 0, the data is 0. And then as we start moving away from 0, 1 degree, another degree, immediately we start getting non-zero data. But we know that the particle cannot be pointing towards the top hemisphere of the universe. Nevertheless, so what we see is that even though, right, this has to be the conclusion. I mean, what else would you assume? Problem is that we just don't know. Anyway, so what we see is that when this, right, we're assuming that this particle is pointing at the top half of the universe. If that's our assumption, then particle 2, this is the data for particle 2, the black dots is the data for particle 2. Particle 2, if we test it at the same exact direction, we get 0% of the time detection. But as soon as we start testing a little bit off, 1 degree, 2 degrees, 3 degrees, we already start getting data. So how could this be? Right, this means that, right, so again, we assume this is, so you could say that this is a paradox, but even this is not a paradox. Even this we can live with. We can live with this. And I don't see an issue with this. I mean, I could easily reproduce, I've reproduced the black dots. I've modified the blue line to fit the black dots and to fit the red line. So I don't think that he got this right. So if we assume that particle 1 was pointing up, therefore pointing at the top half of the universe, and therefore we detected it up, and therefore the right particle, particle 2, must be pointing at the bottom half of the universe. So particle 2 is pointing at the bottom half of the universe. Nevertheless, right, particle 2, this is the degree. This is 90 degrees, 45, 12, basically 7, 8 degrees. It's already non-zero detection. So even though we know it's pointing down, so this means one of the explanations is that even as particle 2 points at the bottom half of the universe, let's say even perfectly, it perfectly points at the bottom half of the universe, some of the time, and this ratio is a cosine squared of half of the angle. That is the equation that fits the data. So cosine squared of half of the angle gives you the probability of detecting the particle. But notice that the particle is pointing at the bottom half of the universe, and still we're going to detect an up. Not a perfect up. If we would try to detect a perfect up, we would get 0. This doesn't make any sense. This is weird. This is weird, right? Because the fact that we got a detection up, that doesn't mean the particle is pointing up. Now notice that particle 1 and particle 2, we ran the measurements simultaneously. The way he explained it is we ran particle 1 and later we ran particle 2, but not fast enough for light to travel. So we might as well have run 1 and 2 simultaneously. So no time, anyway, there was no time for the information from for particle 1 to have reached particle 2. You know what? I wonder what would happen if we would actually run the experiment of particle 2 first, and then run the experiment for particle 1, but just not that would be so funny. But we would reveal that doesn't make any sense. Anyway, look, the fact that we got an up for particle 1, that doesn't mean particle 1 is pointing up. Particle 1 could be literally pointing anywhere. We know from this graph that as particle 1 is detected up, that particle 2, if we measure them both in the same exact direction, then particle 2 is 0 times up. That in itself, that already doesn't make any sense. That makes no sense. And the blue line is a prediction. That in itself doesn't make any sense. Because particle 1 detected up doesn't mean particle 1 is up. Particle 1 could be pointing anywhere. Maybe with just one exception. Maybe it cannot be pointing down. But it could be pointing anywhere, and we would still get a detection pointing up. Let's see. Particle 1 could have been pointing anywhere. We just got an up detection. But that's just with there's always a probability to get an up detection that seems to be related to the cosine of the angle, cosine squared of half the angle, whatever. But getting an up doesn't mean the particle is pointing up. It doesn't mean anything, actually. The particle could basically be pointing in any direction, 360, any direction. Some of the times we'll get an up even when the particle is almost pointing down. But weirdly enough, the two detections are always opposite. Okay, so for this, we need to add a hidden variable. For this, I have no explanation. If it's the direction of the particle, then there's no way to always to get even the blue line. There's no way to get anything like this. Why would the two particles give opposite results from measurements? Where it seems that any measurement is basically random. Any measurement is related to cosine squared of half the angle. But half the angle is just almost 0. So it's basically never 0. To get an absolute 0, that basically never happens. That's impractical. So it's always non-zero. That means the particle 1 might be pointing in any direction, literally. And particle 2 might be pointing in any direction. They must be pointing in exactly opposite direction. But particle 1 might be pointing in any direction, might be pointing almost perfectly down. Yet we got an up. And particle 2 therefore must be pointing almost perfectly up. Yet we get practically 0 if we measure it up. That's weird. It's as if they conspired to be detected always in opposite directions, regardless of where they're pointing. So for this, you need a hidden variable. So there is a hidden variable, and this I wrote a paper about. This is the paper. And this is the Google collab. I played around with it last night. Let me see. What did I change? I don't know. Yeah. This is the first one. Let me see the angles. Um, oh, 0, 120 to 40. So it didn't save. Okay. Mhm. I'm gonna need more coffee. This is so difficult. Ali la 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 la. This is so confusing that my intuition is somebody got not somebody. Everyone must be confused by something. Everyone is confused by something. This is way too confusing. Way too confusing. I've seen them getting lost on things that I'm convinced of. With ether, with black holes, I've seen them being wrong. I know they are absolutely wrong on fundamental stuff. As smart as they are, including Einstein, I appreciate all of them. You see, I always listen to them. I appreciate them. I appreciate their wisdom and their high IQ and their knowledge of math and everything. But I know that they make mistakes. It's clear to me they make mistakes. And this is, I think there is something confusing here. Anyway, that's my intuition. I'm not making any claims for now. La 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 la. What? Nirvana 413. La 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 la. I wish I could see messages. This is so terrible that I cannot see messages. Messages. La la la. I'm gonna make myself more coffee. I'm too tired. Mhm. Anyway, from this is all right. So how did I resolve it? So I resolved it. There was another paper. Let me show another. I didn't write the paper for the other simulation. Let me show you the other simulation. The first one. Wait, for the first one, I didn't use. This is the first one. I don't think that's the second one. So where's the first one? Oh my God, I'm falling asleep. Yeah, I don't think I used a hidden variable. I called it a hidden angle, but it's not a hidden variable. Yeah, this is a complete and utter confusion. Everybody's so confused. This paper doesn't mean anything. This paper, this code is very important. So in this code, there is a random value. There is a hidden variable. Exactly, random value shared between entangled particles. And this randomness value determines the result of the measurement. So when particle one, it doesn't arbitrarily decide to be measured up. No matter where it's pointing, that's one parameter in the equation, but there's another parameter in the equation that together these two determine the result. Otherwise, there's no way to create this graph. This graph must have a hidden variable. Even this point, 0, 0, the blue line doesn't make any sense. The blue line, you cannot say 0, 0. You cannot say that if particle 1 was detected up, therefore particle 2 would be 0 detected up without a hidden variable. So even for that, you need a hidden variable. Okay, so I created a hidden variable. I don't think I saved the last. It doesn't remember. There it is. This is the code. Let's see. Let's see what happens. How does it react now? Because it no 2 day on no 2 days does it give similar results. So this is the sine squared. That's a good sign. And the cosine squared, that's a good sign. So this probably works perfectly. Maybe, I don't know. Let's wait for the code to complete and then we'll test it. But I think I'm gonna have to stop asking ChatGPT to write the entire code because it becomes too cumbersome for ChatGPT to rewrite the entire code every time, because ChatGPT is just too unreliable to write identical code twice in a row. Oh my god. La la la. Let's copy and see what it gives us. I'm waiting for it to complete. I'm just looking at the code. Did it get the right angles? Yeah, 120, 240. Yeah. Okay. So it's the same prompt. Differ between the two tests. You can run the script and observe how the results differ from the two tests, highlighting the non-classical correlations of entangled particles. I don't know what you mean by that. I mean, the only way measure outcome, the outcome depends on the angle, randomness. Anyway, the question is, this is Bell's test. So the question is, what happens in the lab? This is the best I can give you. Is it? So what I'd like to add, I want to add to the prompt one more thing. So the first part, write a Python script, generate random value, create two particles with random opposite spins, and this random value, each spin will be the number between 0 and 360 degrees. Call on both particles measure, where measure is 0 degrees. Measure needs to return up or down. Up or down will depend on difference between the particle's spin direction and the measurement angle, but also on the particle's value, random value. The random value should be weighted more lightly. Yeah. If the measurement angle is the same for both particles, then the two calls to measure should return up, down, or down, up. This is since the two particles spin in opposite directions. Should not call random. Rather, measure should use the random value that was passed to the particle creation. Measure should employ cosine squared. Okay. 1,000 times. Plot the results. Okay, so I want to add another output. And that is just like in this internet stunned after an attractive biological female human of healthy weight wins Miss Universe pageant. So this is percentage in that direction, measurement direction. Percentage in that direction. Let's move this right next to the prompt. Let's move the prompt all the way to the end and this right next to it. I need more light in this room. This room is too dark. Oh my god. I'm gonna take a break to drink the coffee very quickly. How long have we been killing ourselves? Oh, just over an hour. What happened to this thing? Okay, there it is. So we want there a percentage in that direction. There's an y axis percentage in that direction. X axis measurement direction. So plot the results. Graph 1. Graph 2. Where's graph 3? Ron Bell's test. Where's graph 3? I think this is graph 3. Run Bell's test, where Bell, each part is of separate direct detector, each detector, possible measurement, create 2 new particles, plot, graph. Anyway, this is graph 3 after that. Bell's test. So today, Biden said to Ukraine, yeah, go ahead, defend yourself. So Putin said, I'm going to use nuclear weapons. This is war. This is war. So the right wing and the left wing extremists are saying, World War III, World War III, World War III. We have to surrender to Putin. We have to surrender to anyone who makes any threat. We need to surrender. It's like, the most powerful empire in the history of the known universe needs to surrender to anyone who makes any threat against it. Because World War III. Oh my God. You know that there is such a thing called betrayal, and for that you get executed, especially if it's war. Maybe the Congress should declare war just so that we can start executing people who are betrayers, who are betraying us. We have to surrender to Putin. We have to surrender to Putin. We have to surrender to Xi Jinping. We have to surrender to North Korea. We have to surrender. Otherwise, we're gonna have World War III if we don't surrender. Okay, copy code. We have to surrender. We have to surrender immediately. We need to surrender. We need to surrender. We need to surrender. La 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 la. I wonder what it's gonna look like. If it's gonna look anything like what I'm expecting. Oh my God. Is it the first time I'm running it? What? Hello? Focalin.
Yeah,
Hello, sir. How are you?
good, bro. What are you doing?
Trying to solve quantum entanglement.
Where are you from?
I am from, I don't discuss where I'm from actually. I try to maintain my anonymity. I am anonymous.
Feel like you're like in Europe?
Maybe it's possible. Jesus.
No, you gotta be from Europe. Just know you're Asian.
It doesn't matter. Are you Asian?
No, just like,
Are you
where you
black?
from? Half, yeah.
Yeah, I can tell.
How can you tell?
Uh, the way blacks, pronounce and talk, you can tell from the way someone speaks. There's just a tinge of, I think maybe it's genetic that influences, and the voice and the way, the intonations. I don't know. I usually get it right. So, but
I mean,
I
I'm
don't.
half black. I'm not full black, like 100%.
Yeah, but black genetics are what do you call it? Not allele. The opposite of allele. I don't remember the exact word. Anyway, what do you want to talk about? What do you believe in? What's your belief? Are you,
In terms of what?
you a Christian?
Yeah,
Okay, so you believe there's a God?
yeah.
I believe you're lying.
What, that I'm Christian?
No, I mean, if you claim to believe in a God, then you're lying. You don't really.
I I
No,
I believe in a creator, bro.
no, you don't. I don't
Why
bel
don't I?
I don't believe you when you say that. I don't believe you. I believe you're
What makes you
lying.
not believe me? What makes you think I'm lying?
Um, what makes? I mean, that's like saying when anyone lies, what makes you say they're like if you've ever detected anyone lying, if you ever
Yeah, I have. But like, what would you?
so
If you
every
don't know someone, then it's pretty
you,
hard.
you never know, you never right, you never know that someone is lying. They're telling you, no, no, I'm not lying, I'm not lying. So
You
how do
gotta
you
ask
know?
follow-up questions.
Yeah, right, but you never know. It's always
Never 100%.
what?
It's never 100%. Yeah.
Exactly. So it's never 100%. But in general, when people say they believe in God, they're lying. So we can go through the
Why in general?
why in general. Okay, so what's your definition of God? How do you define God?
Creator.
Okay, so that is obviously a lie
It's a lie.
because yeah, because right, you don't understand how this universe was created, right? The very
Mm.
creation of this universe, we can never understand it. Ever. Right? The beginning of everything, this is not something we can ever understand. That is something that is absolutely beyond our comprehension.
I mean, yet right now, yes. But
No,
like as time goes on, we're gonna understand more and more.
no, this will never
Yeah.
be
Yeah.
resolved. No, absolutely
So you think
not.
we're just? Do you think us understanding the world and the history of it is just at this? It's stuck.
Not the
Like we're
beginning.
not progressing.
We will never ever understand how everything begun. So let's say tomorrow morning, aliens, the most advanced aliens land in the front lawn of the White House and they say, "We are the aliens. We have been in the universe since its beginning and we know how it all began." I can tell you with exactly 100% certainty that they are lying. They don't know how it began. They weren't there when it began. They were there right after it began, at best. And there is no way to understand it. There's no way to understand the beginning of everything. There's just no way. We're trapped in
So
this.
so what is your point?
You're lying. When you say you believe in a creator, you don't, because you don't understand the creation.
I
So you
have to
cannot
understand everything to believe
exactly.
that there's a creator.
So you're a
If
liar. That's a
if
liar.
if I create things, I create food I eat.
Yes.
The screen I'm looking at is created. Then like I'm just gonna
I
use
know, but
everything in life and then look at the earth and everything else and say, well, I mean, it has a creator too. I'm not just
the
gonna say, well, it
creator
doesn't
of
have a creator.
the creator of
That wouldn't make sense to me.
the creator of the earth I can live with. The creator of the galaxy I can live with. But when you say the creator of everything, the creator period, no, that's a lie. You have no conception of the creation. You don't understand it. Therefore, you cannot know, you cannot believe in a creator. That is a lie.
So you think people should believe there's no creator?
Well, people should stop lying. I think that people who call themselves religious are liars. They live a
So you
life.
don't,
What?
but they're not saying it's like a fact. They're just saying that they believe it.
That's a lie. They don't believe it.
They
That's like
can't.
saying
Why can't they accept it as
that's like
true?
me saying I'm not saying it's a fact. I just believe 1 + 1 is 17.9. I'm not saying it's a fact.
No, no, no.
Yeah,
That's
yeah.
different.
No, it's not.
That's mad.
It's it's
No, it
this.
is. When you're
It's
when you believe.
it doesn't
Oh
matter.
yeah, I believe he's gonna do right here. It's not like, but
No,
it's not a fact. You just said your example was I believe, and you were seeing a math problem. No, we already know the answer to that.
and the answer to the creation is we don't know. This is beyond our grasp. To make any claims,
But you can use what you do know.
but you
So
don't.
what you do know is that when you experience life, things are created. Things are not uncreated and coming from uncreated things. Things are created. So if you use that, then you could just say, okay, there's a creator.
No, you
You
can't.
can't.
It's a lie. Then there, right? We started from how do you know somebody's lying, right? You never know somebody's lying, but it's never 100%. So I'm not going to say that I know 100% anything, but
But if
as
someone accepts it as truth, then you can't just say they're lying. They just accept it as true. That they're not
that's
lying. They're
that's
telling the
accept
truth.
they're accepting a lie as a truth, but
I
it
mean, no,
doesn't
they're
make it.
accepting
It's
they're accepting something as a truth. That doesn't mean they're lying.
Yes, look, as we said in the beginning, to me, that's as much of a lie as is possible for there to be a lie. There is no greater lie than to claim you believe in a creator. There is no greater lie to me. I cannot imagine a bigger lie. That's it. If you choose to live a life of lies,
But they're not lying. If you get the polygraph or whatever it's called, if you get that and they test it, they're gonna pass. They won't it won't even be close. Like if you do any type of like test to see, they're telling the truth that they believe that. You're saying that they're lying that of the statement when they say, I believe that God is real and he's a creator. You say, oh, you're lying. No, I
look,
believe it. That's the
if
truth.
after
That's
me
the truth.
it's possible that they're too dumb to understand that they are promoting a lie. It is possible. Just like we said in the beginning. I never know. Like when
I
somebody
mean,
lies to you, when you catch them lying, you never know. Maybe they're too dumb to understand it. Maybe they are dumb and they're just spreading misinformation. It is possible. But
but you're saying promoting and like
yes.
spreading, right?
Yes.
If you're asking someone a question, they're not promoting. They're just telling you they're answering the question. Not everyone that believes in God is promoting it
Okay, look, it's
and,
possible. It's
and
possible that you're too dumb to understand. I'm sorry if it hurts your feelings, but it is possible.
nah,
Look,
it's the internet. It's the internet,
yeah,
bro.
look,
It doesn't mean
it's either I'm not. Let's not say
I'm not.
you. Let's not say you. So it's a person that says they believe in God. Okay, it's possible that they're too dumb to understand that they've been lied to and they're spreading misinformation. But more likely, they are.
Why would you assume that they're spreading misinformation? Why would you be assuming that they're spreading it in the first place? A lot of people that like believe in God, they don't really care. They just live their life, work, and really care to
No,
like
no. People
spread
that
it.
believe in God are always, it's always
You
as
can't
part.
generalize that.
What?
You can't generalize that, bro. If you get all
As
the people that are working, do you think that the people that are working are in their workspace spreading? Oh God, no, it's maybe the people on the internet, but there's a lot. Most of the people that are working are just working, going home, and experiencing that. They're not out spreading this. They're not at work spreading this. They're just working, bro, doing their day-to-day
look,
life. You
look.
can't say like spreading misinformation.
Okay, look. It's like we said in the beginning. Like, how do you know that they know that they're lying? Well, you never know. It's never 100%. But as far as I'm concerned, it's misinformation. Maybe they're too dumb to understand it. Maybe they understand it and they're doing it for for whatever reason they have to spread disinformation.
I don't think they're lying though.
Uh,
I think the lying. I think if someone was lying, they say believing. If someone's lying, is they're saying that, but they really don't believe in God. That's lying.
that's
If I say I believe in God and you're saying I'm lying, that means that I really don't believe in God.
so.
But
I'll
I'm just
tell you
saying it. Not
some
saying it.
some of the times when I have this discussion with people, they're like you and they're saying like, man,
I-
it's not a lie.
Yeah,
We're not lying. That's some of the people. Some of the people, they start playing word games. Like yesterday I was talking to this Muslim. He kept shutting me up. He said, stop getting off track. The talk of I was trying to define God. He wouldn't let me complete the sentence. He kept telling me, stop changing the topic. When I was trying to define God, he said, stop changing the topic. He wouldn't let me finish a sentence. So
yeah.
so some of them, they use word games to shut you up. That's when you know they're liars. They don't want to talk. They don't want you to expose their lies. But
But that's not a
sometimes,
lot. Like that. That's if you're asking these questions, that's like you're. I don't know. If it got to be a fallacy because when you say, "Oh, you're lying," bro, they're not intentionally telling you this, knowing it's not true. They're not doing that.
but if I'm
Like a belief, then when they have like you brought an example about the facts, you can't bring an example about a fact with math to a belief and believing in something is different than a fact.
yeah,
Someone that has a belief, they're holding that to like self experiences, etc. They're holding that to that their
yeah.
truth. That's what that individual holds as true.
Are you
And then
16?
a fact is a fact. No, I'm 18. And then a fact is a fact.
No,
You're like mixing the two.
no.
And
Anyway,
that's not lying, it's telling you something when you know it's not true. That's no.
yeah, I
That's not lying either.
yeah. Look, as I said, so yesterday I was talking to this guy. He wouldn't let me finish a sentence. Other times you talk to people and they start, you know, talking to you, like make fun of you and attack you and try to get you upset. And those times, these people are liars. They don't believe in God. But sometimes you talk to people like you and you're like, hey man, we're not really spreading, we really believe it. And you're not trying to make fun of me and you're not shutting me up and you're not attacking me. So you're consistent. Your behavior is consistent with someone who's not lying. But some of the times when I talk to people who claim to believe in God, their behavior is consistent with someone who is lying and who is now who becomes aware that their lie is being exposed and they lash back and they try to attack
Well,
you.
are those mostly Muslims?
No, I didn't notice it to be mostly Muslims. And, I usually don't
Are
debate. I think it happened like it doesn't matter. You're the first one who's actually not attacking back.
surprised?
Usually they attack.
But I think that when you say like lying, I think that's for something else. That's like it's not like someone is making a
No,
statement that's not true. They're not
no,
making a statement that's not true with and
no.
they're with intent. They're intentionally trying to deceive you. They're not
They
doing that.
they do because when they don't let me talk, they shut me up. They make fun of
That's
me.
just them.
Hmm?
That's just them not knowing how to like debate or talk or
No,
have a.
no, no,
I
no,
don't think that's the rocks from them trying to deceive. I think that that's it's more probable
no.
for them just not they don't know how to
N-
debate. Most people are just gonna argue
No,
and talk over you.
no, 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 no. Then
So 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 let me
they're
ask you a question.
yeah. Hmm.
So you think it's more probable that they're trying to they're saying something that's untrue and their
Hmm.
intent is to deceive, or do
Yeah.
you think it's more probable that they just don't know how to debate and a lot mostly most people when they
No,
argue they talk over people.
no,
It's a
no, no,
probability here.
no, 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 no. Like you're nice, and like I can tell when I'm debating someone who's like a very advanced debater. Look, an advanced debater just means you know how to play word games, and that's what they do. They learn all the tricks of how to play word games.
Oh, they just all they do is debate. That's all it is. Like those
Yeah,
people, they just it's not even working. It's just they are like a tryhard. They're just tryharding, debating all day, learning all the
yeah,
fallacies,
yeah,
learning literally all that. So then when you say something, they're gonna say, "Well, that's this type of fallacy, that type of fallacy, that's this
yeah.
type of fallacy, that type of fallacy." Well, actually, this is like they do that, and then like you can't argue. You just can't really say much about it. They're just spamming that. But like I think you just have the you're using the word in the wrong, like you can't use the lying word in a beliefs. Like someone's talking about their belief, you can't
Of
say they're
course I
lying.
can. Of course I can.
What a truth like for it to be like, of course you can say anything, but in terms of like, is it the right thing to say? No, it doesn't make
Yes.
sense if you were to
Yes, it
say
does.
lying and they're believing.
Yes, yes. Yes.
Because the probability, when people talking over you, they're just and not listening, etc. They're just they don't know how to argue, which most people don't know how
No,
to argue. Most people don't know
no,
how to argue.
no, 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 no.
So you disagree with that. You said no, you disagree with that. You disagree with most people don't know how to argue.
I'm, I'm not this guy. I don't know statistics. I just know that when it
No,
happened,
we
listen, when it
yeah.
happened to me, that, most of the time when I talk to people about this proposition, they start playing very advanced word games and very, they play with you and they play emotional games. Like I
What
had
do you
this
mean
guy
emotional games? Break it down.
emotional, like I was talking to this guy and he said, I can prove God, like very high level complex proof. And I showed him that his proof is insignificant, and his response was, "Do you feel me tickling your asshole?"
What the fuck?
Yeah, 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 yeah. Exactly, exactly, exactly. So you're not gonna
That's
tell
just
me you're
weird,
not gonna
bro.
tell me a guy like that was talking very advanced proofs and very advanced philosophy and terminology, very
He doesn't
advanced.
know how to debate.
No, that no, no, no,
So
no,
what do
no,
you so
no. You cannot.
you disagree with that, but he said that in the middle of the debate. Like he's debating, but then all of a sudden he's trolling.
It's not
Like
all
that's not
the.
a serious debater. Like
No, no, you cannot say that. No, no, no.
most people
When
don't know how to argue, bro.
no, 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 no. This is he was playing emotional games. He wanted to basically, get me to react emotionally so that we would stop exposing his lies. The last thing you can say about someone like that is that he's just trolling, he doesn't know. No, no, no. He was very
He's
serious
trolling.
and he was
Yeah,
using
but
very advanced logic and very advanced
he's seriously
philosophy.
trolling. He's trolling.
No,
You
no,
literally
no,
just said
no,
what he said.
no, no,
So
no,
right there. So what do
no.
you call that? Him saying that. Well, what would you call that?
I explained it. That's being a liar. And
A lie.
when your lies are being exposed, then you're trying to change the time. You're gonna use
Yeah, you could say he's
any
playing around. He
you're
doesn't.
gonna
He's not.
you're
Yeah, he's
gonna
not fit. Yeah, that sounds
you're
good. My
going
bad. My bad.
to
That sounds good.
when you're a liar and you've been exposed as a liar, at that time you're gonna want to play any which you're gonna pretend like, oh, I wasn't debating, and you're gonna start, pretending like you're a troll, and you're gonna play any which game in order to not concede that you were trying to lie and you've been exposed and you lost the debate. People, in order to not lose a debate, they'll go to great distances. And you can call it any name you want. You can say, "Oh, he's just trolling. Oh, he doesn't know how to debate." You can say whatever you want. But at the end of the day, this is completely consistent with the proposition that these people are liars. And that is exactly the reaction that you'd expect from a liar who is being exposed for his lies. So it's completely consistent, right? We said in the beginning, how do you know that they're lying, right? You never know 100%. But if you're feeling that you're doing a good job and you're exposing their lies, and their reaction is not to defend themselves, but rather go cuckoo and trolling, and and saying, I wasn't debating, who's debating, and and stuff like that. All right, now they switch from being the biggest brain, they switch in an instant from being the biggest brain in the universe to the tiniest brain ever witnessed. That's part of the game.
Yeah, yeah. Maybe that person was
Yeah,
he was running away.
maybe.
I mean, yeah, I don't know. I wasn't there, etc. I don't know any of it, bro. Like he was
Yeah.
probably running away from what it sounds like. But like, if someone says they have this belief about something, then they're not lying. Because it's not like they're saying like they're not saying something untrue with the intent to deceive you. They're not saying that. They're just telling you what they believe, and they
Yes,
they
it
might
is.
tell you
Look,
what
it
they
doesn't
believe.
matter.
They might.
It doesn't matter. It doesn't matter. It doesn't.
No, it does, bro.
Not to
You're
me.
using the wrong word.
No, there's no better word. This is a lie. The belief in God is a lie. To claim that you believe in a God is a lie. There's no
Okay,
bigger
let me
lie.
ask you a question. Let me ask
Yeah.
you a question. If someone
Hmm.
almost died, right? Which
Yeah.
like let's say they got in a car crash, etc. And let's say they just after they felt let's say they felt warm, right? And it's really cold, etc. And they survive and they say, yeah, I know God is real. I believe in God. And they hold their belief to believe in God based on like that incident and them not
Hmm.
dying. Are they
Hmm.
lying?
Well, I don't know, but if I talk to them, and in the beginning they're great philosophers and they have all the answers and they know all the techniques of debating, and they're you can tell they're good debaters and they're very high IQ. And then you expose them, and you show them all the evidence that the belief in God is a lie, and suddenly they switch from big brain to tiny brain, and they start playing word games, and they start pretending and like they don't whatever, don't understand you, or what do you mean by this, and define that, and that's undefined. And and you can tell when somebody switches from debating you honestly to debating you dishonestly. And you tell them, listen, I feel that you're debating me dishonestly. I feel that you switched. In the beginning, you were making good.
So you're basing them lying on you debating them and exposing them, quote unquote.
It's whatever, I come to the conclusion. Look, during a debate, I'm talking to the person. I'm telling him, listen, we were talking. You were smart. Everything was nice. You were presenting your evidence, and I was presenting mine, and I made my claims, you made yours, and I made my arguments, and you made yours. And at one point, it became clear that I mopped the floor with your face. And at that
So
point,
you're basing it, yeah. So you're just basing it off of you're basing them lying off of you debating them, bro. That no, like, bro, you have. So do you believe that n- God not existing is a fact
I
necessarily?
no, it's a lie. It's a lie. It's like it's similar to. Do you believe that 1 + 1 = 10.75, do you believe that that's a fact? No, it's a lie.
Can't do that.
One
You
plus
can't
one is
use
two.
factor.
Look,
You can't use
I don't
factor.
know.
You can't use factor
Whatever.
belief.
Okay, I don't.
That's
It doesn't
look.
matter.
I'm
It
on
doesn't.
point. What fallacy is that? But I don't know. You're like you're using beliefs and then you're using. No, you can't do that. Hold on, let's figure out what fallacy that
It
is, bro.
doesn't matter.
That's some fallacy.
Don't matter. Don't
You're,
matter. It don't matter. It doesn't
no,
matter.
it does.
Nah. It's fine. It's fine. It's no big deal. Look, we don't have to agree. I told you my position multiple times. You said your position multiple times. At this point, we're just, we're repeating. We're doing a rerun of the old Star Trek shows. We're wasting time. It's cool. You're a cool dude.
Okay.
I'm gonna go drink some
I
coffee.
found the fallacy, bro. It's the
What's the
category mistake, the category error, bro. That's the fallacy you
No,
keep using, bro.
no,
Yes,
it's
it
not.
is, bro. You have to like think
No,
like you can't, bro.
category
You
is
can't do it.
different. Category is different.
The category mistake, that's the
Category
error.
mistake means the sky is 7 or 1 plus 1 equals purple. That's a category.
Yeah. Like these things, yeah. Like the fact, like you using this example of math, that does not belong in the category of
Yeah,
belief. Same with
no,
lying.
no,
And
it
that
doesn't.
lying isn't
It
in that
it does.
category, bro.
It
Lying isn't
doesn't
in that
matter.
category, bro.
It's fine. It doesn't
That's like
matter.
saying someone's opinion isn't true.
Okay, it's fine. It doesn't matter. It
It's,
doesn't matter. I'm gonna
it's the
go.
category error, fallacy,
No, it's
bro.
not.
All right, bro.
All
Nah,
right,
it
man.
is, bro. See, you're not even accepting it.
It doesn't matter. It doesn't
You gotta
matter.
accept it, bro.
No, I'm not gonna.
How
Uh,
you gonna debate if everything doesn't matter and you're not gonna accept it? Like, bro,
I'm not
you're
saying
never gonna.
everything doesn't matter. I'm just saying this specifically doesn't matter. It's not important. It's like
Then you shouldn't debate then, bro. You have to like
I
understand the other
shouldn't.
person's perspective and be open, bro. You're saying, oh yeah, what I'm saying doesn't matter. Oh yeah, this doesn't
No, I'm
matter.
not saying what you're saying doesn't matter. I'm not saying you're I didn't say what you're saying doesn't matter. I'm saying it
Yeah.
doesn't matter. So we've said enough. I said my piece. You said your piece. We
All right,
exchanged
bro.
ideas. We're cool. Everything is fine. I'm gonna go
All right,
kill
bro. Peace out.
myself because
Peace
I'm
out, bro.
tired. I'm gonna go drink some coffee, man. I'll see you later.
All right, bro.
All right, man. Bye. La 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 la. I gotta go get some coffee. Okay, let's take a break. Let's take a break. I need to analyze this output. I don't know what this output's all about. La 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 la. Percentage. This is actually very interesting. Measurement angle. This is the history of the ups and downs. This is the angle. Whose blue is up, but this is particle 2. Percentage in each direction versus measurement angle. So he kept changing the angle. Is it? I mean, it seems to be a sort of a sine wave. At around 180 degrees is the maximum, and around this is is this does this make any sense? What do we want? What is this data? I don't know what this data is about. I'm trying to understand because I didn't give it exact instructions. The instructions are not so good. La 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 la. Oh, yeah, I'm gonna have to start writing the code myself. I don't see any way out of it. Anyway, now the code is 10 times the data is 10 times as long. Let's see what happens this time. Is this ever gonna end? 47 seconds. Ceases. Ceases mucho tiempo. Ceases. Is it running on my CPU? Mine and CPU. Wait, what? Enable browser notification in settings to get alerts when execution completes. ELO. ELO. Do you ELO? Yes, I ELO. Oh my god, it shouldn't take this long. Something is wrong. Plot 3 Bell's test. Amber doesn't talk to me anymore. She's upset at me. La la la. Where is the this? What is going on? Is it still not done? 2 minutes. Why is it taking so long? So this is measure. Measure hasn't, I don't think it has changed. Cosine, sine. Measurement angle. 0, 360. All possible measurement angles. Random angles for Bell's test. Bell outcomes. Result containers. Range. La la. Okay, so within num tests. Where's num tests? Okay, so it's 100,000 tests. Generate random spin. So each time it generates a random spin and an opposite spin and a random uniform number. Okay. Then particle A is spin A and particle B spin B with randomness. Particle A measured 0, particle B measured 0. This is incorrect. Measure at 0 degrees for both. No, that should never happen. That's completely incorrect. That is very interesting. That's a good measurement. That's a good what do you call it? Calibration. Like you do want to see like run 0 0 consistently. Make sure that they're always opposite. Record correlation. I guess this is for test 1. And then record outcomes by measurement angle. And now go through all the measurement angles. No, that's incorrect. Up and down, that doesn't make any sense. That doesn't make any sense. You measure a particle, but didn't you already measure? You already called measure with 0. Now you're doing measure at angle. No. No. Yeah, they're both in this. Oh my god, what a complete mess. And Bell's test is, and it's still running. Forget it. This is a complete waste of time. Okay, forget it. If I do Control Z, so only 10,000, that runs quickly. But we know that it's incorrect. I see the code. The code is incorrect. I mean, this 0 0 and and then you measure angle. This doesn't make any sense. I never asked for this test. Bell's angle A, Bell's angle B. No, they can't be. Oh yeah, that's good. That's good. Both are random. That's what we need. Both angles must be random. I mean, especially for Bell's test. Anyway, it's a complete nightmare. Oh my god, what a complete nightmare. Yeah, I need to take care of my the code myself. I can't have. Oh, it's finished running. Yeah. So I don't know what this is all about. This looks like at around 150. Yeah, it looks the same. I mean, there is a high point at 150 and again at around 320. What is this? I don't know what causes this. And this always looks the same. Anyway, I'm going to get some coffee and we'll come back to discuss this. I don't know what to do with this. This is a complete shite show.